So in our last lesson, we learned that the simplest way to solve a quadratic is to take the square root of both sides. And so, if we have a problem like this, and it is x squared equals 4, then we take the square root of both sides, and that gives us x equals plus or minus 2. Or maybe something like this, where you have x minus 2 squared equals 5. And you take the square root of both sides, and you get x minus 2 equals plus or minus square root of 5. So x equals 2 plus or minus square root of 5. So these are all about having this perfect square on one side equal to some number, and then taking the square root of both sides. So a natural next step is to say, well, how do I, if that's such an easy way to solve a quadratic, how do I put something in that form? How do I find something that is going to be just like that? Well, to do that, we need to make sure we remember, well, what does a polynomial perfect square look like? We've done this plenty, and that is if I have something like x minus a squared, that is equal to x minus a times x minus a, which gives us x squared minus 2ax plus a squared. And so a polynomial perfect square always has the form where 2 times something gives me the coefficient of x when the coefficient of x squared is 1. And then whatever that something is, a, if we square that, we get the third term of our polynomial equation. So for example, if I've got a problem like this, and I said, what do I need to add to x squared minus 6x to make it a perfect square? Well, I analyze this and I say, well, we've got this negative 2a in here. So what does a need to be? A would need to be negative 3. So 2 times negative 3 gives us negative 6. So if a is negative 3, then we square it and we get 9. And now this is transformed into a perfect square. And so that is the general idea about how to complete the square. And what we end up always doing is whatever, we write it in a way so that we get 1x squared. It's always got to be, you need to remember that. It's always got to be 1 times the x squared term, plus or minus some value of x. And then to complete the square, to find the thing that we need to add to it to make it a perfect square, we just divide by 2 and we square it. So for example, if we have a problem like this, x squared plus 4x plus 3, which this is one that we could solve by factoring, and we'll show you that in a second. But if I wanted to solve this by completing the square, here's what I do. I say, what do I need to add to this so that I have a perfect square? Well, what I end up doing is I first subtract 3, and I think, okay, x squared plus 4x, what do I need to add to it to make it a perfect square? Well, half of the 4 is 2. That's what our a value is going to be, because we want 2a. So we divide that coefficient of x by 2. 4 divided by 2 is 2. 2 squared is 4. And so if I add 4 to this, x squared plus 4x plus 4, and then I add 4 over here, I get x plus 2 squared equals 1. So I took this equation right here that did not have a perfect square in it, and then I completed the square by adding 4 to both sides after subtracting the 3. Now I can do what I did above, which is take the square root of both sides, and that gives me x plus 2 equals plus or minus 1. The square root of 1 is 1, so plus or minus 1. So when I subtract my 2, I end up with x equals 1 minus 2, which is negative 1, and x equals negative 1 minus 2, which is negative 3. And at the beginning of the problem, I said I could factor this. Yeah, this would have factored like that, which we did earlier. X plus 3 times x plus 1 equals 0. So yeah, x would equal negative 3 and negative 1. So our procedure then for doing this, for completing the square, we start by dividing. So the coefficient of the x squared term is 1. So whatever you need to do to make sure that the coefficient of the x squared term is 1, you always got to start with that. Then you need to isolate the x squared and ax terms together. And so what that means is you're going to have something that looks like x squared plus ax equals, and then you're going to have some constant value over here. Then this is the key term. This is the key step for completing the square. You take half of a, square it, and add to both sides. And then factor and solve. The factoring always will end up being, because you're squaring the a, so it's always going to end up being x plus a over 2 squared equals something, right? It's going to equal c plus a over 2 squared, right? That's what you're always going to be adding to both sides, is this a over 2 squared. And when you factor it, it always just turns out to be x plus a over 2. It's a really easy way to factor. So here are some examples of this. And these are you're just solving these equations. So you've got x squared plus 6x minus 11 equals 0. You're asked to solve this quadratic equation. It does not factor easily, so we can't solve it by factoring. It's not already in a perfect square form, so you can't take the square root of both sides. And so we're going to use the completing the square method. So here's how we do that. First thing we do is we make sure this has a coefficient of 1, which it did at the start, so that's good. Isolate the x squared term and 6x term. Add 11 to both sides. Now the key completing the square step, take half of a, this is a, half of 6 is 3, square it, that becomes 9. Remember, in an equation, if you add something to one side, you have to add it to the other, and so we're going to add 9 over here. And so that's going to give us then x plus 3 squared. Remember, when you factor this, it always turns out to be half of that coefficient. So x plus 3 squared equals 11 plus 9, which is 20. Take the square root of both sides. Don't forget that the square root of 20 is going to be plus or minus. Then you need to simplify if it can be simplified. 4 goes into 20, and so it's going to be 2 root 5. And then finish by solving for x by subtracting 3 and realizing that there are two answers. You can either write them as -3 plus or minus 2 root 5, or you could write your answer as x equals -3 plus 2 root 5, -3 minus 2 root 5 as your two answers to this equation. A couple more examples. You got x squared minus 5x plus 2 equals 0. So on this one, we isolate the x squared minus 5x term. And so we get this, x squared minus 5x plus something equals -2. Now on this one, when we take half of 5, we get 5 halves. 5 halves squared is 5 halves times 5 halves, which is 25 fourths. That's what we need to add to both sides. This is where it's helpful to know that you take half of this term. That's what was squared, and so that's what is going to be in the factorization. So it's just going to be x minus 5 halves. And then -2 plus 5 halves just turns out to be 17 over 4. So now when I take the square root of both sides, I get x minus 5 halves equals plus or minus, well, square root of 17 we don't know, but the square root of 4 does turn out to be 2. So when we add 5 halves to both sides, we get x equals 5. They both have a denominator 2, so we can write it as 5 plus or minus square root of 17 over 2. So 2 answers, 5 plus square root of 17 over 2, 5 minus square root of 17 over 2. We then can look at a problem such as this, where you got 3x squared plus 2x plus 1 equals 0. You're asked to solve this quadratic equation. We're going to use completing the square to do it. So we need to start by dividing through by 3. And so this is going to get a little bit ugly. We have to divide through by 3 because before we can do the completing the square method, we have to have this as a coefficient of 1. So then remember, you isolate your x squared and 2/3 x term, which means I take the 1/3 and I put it on the other side. We then take half of the middle term. So remember, half of 2/3 is just 2/3 times 1/2, which just turns out to be 1/3. This is where students get into trouble. Once the calculation gets a little complicated, is you got to remember every single step. First step is take half of 2/3. That's 1/3. Second step is square it. Don't forget to square it. So we need to take 1/3 squared, which is going to be 1/9. And then I need to have 1/9 over here. And so that's going to give me x plus 1/3 squared. Remember, what goes here will always end up being the thing when you took half of the middle term. That's what it's always going to be. And then on this side, now what's going to end up happening on this one is we're going to end up with, we've got a perfect square equal to a negative number. So when we try to take the square root of both sides, we get the square root of a negative. And so the answer here is going to be no real solution because we can't take the square root of negative. If it would have ended up being positive 2/9, then we could have gone through and actually went through and gotten an answer. But since it was negative 2/9, our answer turns out to be no solution. And so that's completing the square. It's a very important concept. It's one that's used in more than just solving quadratic equations. We use it in other areas as well. So it's really important to get very good at completing the square.